I hope we have a lot of data engineering enthusiasts here because we have Oscar and Rodrigo from Vinted who are going to tell us more about how they do it in one of, I guess, an app we all love here. So yeah, welcome at PyData. Let's go.
Thanks, everyone. I feel a bit like Steve Jobs with Mike here. It's pretty cool. I won't pull out an iPhone that you have to buy again, so don't worry. Instead, we're going to be talking about orchestrating success, and specifically how Vinted standardizes large-scale decentralized pipelines. So for starters, I'll start with a question. Has anyone, or who amongst the crowd, has used Vinted before?
Okay.
I see a lot of hands. So we don't have to use the sales slide deck for today. We can talk about actual interesting things. So for those of you that don't know, Vinted is Europe's biggest second-hand clothing marketplace. Not just clothing, since shortly you see on the bottom right a phone with a case. Now you can buy and sell electronics as well. It's a platform where ordinary people like you and me can put stuff that we no longer use, put it for sale for other people to buy so that it gets a new life. So with that, our mission is, as stated, to make second-hand first choice worldwide. So how are we doing on this mission? So I think we can quite proudly show the next graph of our activity, where we're active in over 20 countries. We have millions of registered members. We consist of 2,000 talents. I have a couple here in front of me, some colleagues here. And we're scattered over 10 different workplaces. So we're getting quite some traction, we're really growing, so it's a good dent that we're putting into our mission. And Vinted at its core is a data-driven company. So with millions of registered members, you can imagine that we have millions of transactions on a weekly basis, and there's a lot of data flowing in that we have to take care of, we have to transform into useful metrics that we can then use to make business decision points. So roughly 10% of the 2,000 talents are scattered across the data realm. And I don't think it's ever a good idea to have a team of 200 people. So I think most companies do this, that we just split them up into specific responsibilities that individual teams may have. So I think one of the challenges we then find pretty quickly is that these teams, that was too many clicks, these teams often need data from one another. So there's a finance that often needs a little bit of everything to monitor and understand the health of the company. But it could be that the supply and the network team need one another, safety, transaction, and so on and so forth. And before you know it, you have an intricate spider web of quite complex communications in between those teams. So how did we used to do this? We had a monolithic repository where everyone would hook in, deploy their products. We used to run this on a scheduler called Uzi. I don't know which amongst the crowd know Uzi, but I do know that if you do, it's the last word you would expect to hear on a data conference in 2025. This is a scheduling platform that has gone into retirement last February. So with this monolithic approach come a few challenges. One of which is ownership. So it's a lot of pointing fingers. Who owns what? Who to talk to? Where to go to? But also decision-making. It becomes way more complex to make decisions. Who do I need to talk to? How do we go forth with a specific plan? So in order to stay ahead of our growth, to remain scalable, we decided to decentralize our teams. So now it looks a bit more like that, where individual teams are on isolated islands, and everyone has their own deployments, their own repositories, and has the ability to make decisions themselves and to move fast. So let's zoom in and have a look at what one of such teams then looks like. So each team owns their own data pipelines. Those data pipelines could consist of some ingestion scripts written in Python, some transformations done in dbt, model predictions in Vertex, and perhaps some more transformations until we do batch processing so that the data lands elsewhere. So all of this now runs on Airflow. We've modernized, I think we can proudly say. But while this enables people to make faster decisions and to stay ahead of the curve, it also comes with its own challenges. One of which is when we zoom back out and we look at these pipelines from different teams, I've color-coded them for a specific reason. Because what we'll find is that each team consists of a different set of people with different sets of skills. So if you completely decentralize, solutions will start taking a life on their own. People will have problems and tackle them with very different approaches. And Einstein was actually ahead of us with this quote saying, everybody is a genius, but if you judge a fish by its ability to climb a tree, it will live its whole life believing that it is stupid. So this is a problem, that we don't want to force people into working in a way where it may not suit the team and every team needs to adapt. In our case, it's a bit different. It is deploying a DAG, not climbing a tree. So we want to find a solution where everyone can make use of it. It's standard out of the box, so we centralize the solution. And through that, all the animals on this picture, all the teams, should be able to climb a tree or deploy a DAG. But that's not the only challenge, because if I take you back to this image, recall that I showed the intricate web of communications. It's not the case that we can cut out these communications. So teams will still need each other's data. And now this suddenly looks like this. So I might need a table elsewhere that someone owns, who to talk to, but more importantly, what if there are any changes on that side, some breaking changes? How do I get notified? How do we make this more explicit? Could be on multiple cases, but it's not one-way traffic. So it could also be that some other team might need something that my team has produced in multiple places. So if we zoom back out, what we have to solve is the arrows here while maintaining the isolation of decentralized teams, because we want the benefits. We want people to be able to make autonomous decisions, work fast, so that we can stay ahead of our growth. So basically this, I think, meme sums it up pretty well. We started as a centralized way of working, didn't scale, decentralized, but then we found that it was too hard to coordinate. So this little guy on the bottom right, that's us pulling the lever as hard as we can. So our goal is here to decentralize a little. So how do we do that? We introduce our generator. So recall the image on the left where I told you about the decentralized teams, and consider that they are pieces of a larger puzzle. And these pieces are scattered. They don't necessarily fit to one another. Solutions differ a lot. So enter our generator. As you can see, we don't really have a nice logo for it yet. So this was the next best thing we could find. It does the job. And what our generator will do is it will mold these puzzle pieces. Yes, that's a tongue twister. It will mold them into a shape where they intricately connect with one another. And what you end up with is a puzzle that can be put together, relatively simple, by Airflow. And now I will give the baton to my colleague Rodrigo, who will explain how the generator works in practice.
Yeah.
And yes, he's wearing Crocs, by the way.
I forgot to take them out. But they make me taller, so we are...
Nice.
So, yeah, thank you, Oscar. I'm going to show you a little bit how this works. This is like the whole landscape. I'm going to focus in each one of these three parts. And the idea here is that we have a user interface that is what people write to interact with the pipelines that they're generating. We have an abstraction layer that allows us to decouple what the users do with what we actually deploy in Airflow. And then we have the code generation and deployment part. That is where we actually do the files that we upload to the scheduler. So let me focus first in the user interface. This user interface has, well, first of all, it's a very boring YAML file. So no creativity there. We went with something that people can use. And we have general settings about alerting and ownership, where to find the owners of these things. We have a lot of DBT repositories that we use. So we have a very easy way to say, like, hey, should I schedule DBT things or should I not? And then we have another part that we call tasks that are all other things that Oscar showed about Python, ingestion, or Spark, or Vertex AI. And in practice, looks something like this. We have the alerting here, so it's just a few keys with some names. And then the DBT settings where we say, like, OK, is it enabled or is not enabled? And we have some extra things. So for example, what to do when dbt starts and run, and what to do when dbt ends. So for example, send warnings. Then we have these tasks that I mentioned, that in this case is, for example, we call them universals because they run Docker containers. So a universal task will run a Dockerized image of whatever you want to do. You can put, I don't know, Rust if you want, that it's now fashionable. And we connect these universal tasks with other tasks using the conditions and assets. Conditions are the things that you need to wait for, and assets are the things that you are producing and other people can wait for. And finally, you have some things like, OK, the Docker image, which command do you want to run, some environment variables, timeout, etc. And the idea of this is that it should be very easy to connect dbt and non-dbt tasks in a way that is declarative. So you don't need to interact with any Pythonic Airflow code or anything that tells you, like, OK, this first comes here. So it's like, just declare what you want, and we take care of the rest. So for example, here you have a dbt model that is an input dbt model. And then in your scheduler YAML, also very creative name for the file, you have, for example, a Vertex AI task that has that input dbt model as a condition. And then you have an asset that is something that the Vertex AI predicted. And then you can also reference it back in your dbt source and end up in your model. So this way, you are connecting dbt models with Vertex AI tasks, and then again with dbt. But this is internal connections. You can also connect with something that comes from another place. So when you are writing your scheduler YAML, you can also declare, OK, all these things that I have in a little produced way, you can use a regex so to make it easier, can be used by someone else. And these are a little bit of our contracts. The ESLO is that this is going to run daily, and it will take 6 hours to run, so it should be done by 6 UTC. We have an asset registry that is a centralized place where all this information from all these teams come together that we later use in CI/CD validation when in some other project you want to use it. So when you declare that you have a global source, then we take care of checking, like, hey, can you actually use this? OK, what is the information? Does it run daily? Does it run hourly? How can I connect my things with the things that are in this asset registry? So then, you connect it like that. And in CI, you can validate that that's all good. And at the end, you end up with some Airflow thing that looks something like this, where you have the other team's DAG that it's deployed somewhere else, and your own pipeline that it's deployed in Airflow. But before getting into the actual Airflow implementation, we have this abstraction layer that allows us to decouple the scheduler file that we show from the Airflow implementation. In case we want to change or upgrade something in Airflow, we have a medium layer that it's in between the two things to be able to take these decisions in a very easy way without bothering the users to upgrade anything or to change anything. And this looks something like this. We get the, I want to generate my dbt tasks. I get my list of tasks that have those conditions and connections. And I create a nice task bag that contains just individual nodes that are not connected yet in any way. After that, we validate dependencies for those individual tasks. And we generate DAGs for each pipeline. So hourly, daily, Monday, 3 times per day, whatever our users want. Not whatever, some. And after that, we have all our little pipelines that are just a graph. So this is not Airflow yet. This is just a simple graph that contains nodes and edges. And finally, we get our DAG bag. So all those DAGs are our DAG bag. We sell also handbags in Vinted, so we really like that. And we have our asset registry that is, OK, what are our new things that I'm exposing? And we have something that we call the scheduler state, that it's a simplified way of showing what a pipeline looks like. And we are going to come back to that because it's going to help us also in CI to take a look at what's going on. And after this abstraction layer, we do have the code generation that is fairly simple. We know that our tasks have some imports that we need to render. We know that we have dependencies with other domains, so we render those as sensors in Airflow. We know that we have task groups and tasks, so we render them with specialized renders for Vertex AI, for DBT, etc. So we have little modules and components that if we want, we can extend. And finally, we have a DAG file, or multiple DAG files for each DAG, and our asset registry state, and our scheduler state, and we call them scheduler files. Yeah, very good name. And we upload those to a GCS bucket, where then our Airflow things and where our CI/CD can read from. So this is a little bit how all the things are connected to each other, and I think that the main interesting part is that the users don't need to understand what's going on in all these things. They don't need to use their time to debug Airflow code or debug Python code. They only need to do something that it's declaring, OK, I want this connected to this. You take care of the rest. But let's take a little bit a step back to the beginning, and let's see a little bit of the developer flow and how does it look like in practice when you are doing a PR. And you can correct me, my team that is here, if I'm mistaken.
After, please.
Yeah. So here's a little DBT PR. I'm adding a source that is another team dimension, so dimension users, for example, that it's a DBT model, and I'm creating a MART, referencing that source and some other mock data. So they only created these two files, and they have that. They push it to GitHub. Our CI runs, and we get something like a scheduler report. First, we see that there are no breaking changes in the project registry. I'm going to come back to that in the next slide. And then we see, OK, what is new? Are there any new DAGs? Are there any new tasks? Are there any new global dependencies? So yeah, well, we have a new DAG that is the daily DAG, and we have new tasks that we have generated with this code. So you see in your CI, you don't need to go to any Airflow UI or anything. You know what happened, what you added, what are you removing, what are you breaking, if anything. So when the breaking happens, you will get a message, something like that. Hey, you are changing the pipeline of something. So it was running hourly, now it's running daily. Probably you're going to mess up with people downstream because it's a big change, right? Or you're saying that suddenly this takes 2 more hours to complete because, yeah, well, you screwed up somehow. So please alert these people. So we have a list of consumers that they need to alert, and then they can coordinate that in that decentralized landscape. They can easily coordinate these little changes only when they need to coordinate things. So they don't need to care about cases where nothing bad happens. And finally, when you merge your PR, we run our generator, and we generate this beautiful simplified DAG, where you have your new model in the middle. You have some things that you see here, for example, a manifest cache for DBT, something that we do on end, for example, for the catalog, or some alerting about, hey, this was successful. And also, that's the power of the generator, because we can introduce these new tasks for everyone in all the pipelines, only changing the generator. We don't need to go repository by repository, adding things and saying, like, hey, well, we need to use this tool now, so you need to change that. No, we just upgrade our version, and it gets done automatically in the next report. And you can see here the hard dependencies part. That is an external task sensor. And it's what I mentioned when you connect with global dependencies, how it gets rendered in Airflow. And I want Oscar to explain this a little bit more, because he understands it better.
Well, we're about to find out. Let's see.
Yeah. Unless I came up with the idea, he was the implementation mind behind it.
So let's see how I will do. Thank you for putting the pressure up a little bit more. What was the next slide? No, I'm joking. So I'll take you back to the cartoons. He did all the serious stuff. So I'm going to try to guide you through what that could look like in a real-world situation, where we have these decentralized landscapes, but we know that teams might use assets from one another. So imagine that within the supply team, we might have a break in one of the tasks. So it could be the case that upstream something failed, or they introduced a breaking change that wasn't caught by tests. This rarely happens, right? So, but let's just, for the sake of argument, let's assume that in this case it happened. So first, we want to alert this team to take immediate actions so that they know, okay, we have a breakage, we need it fixed, so that on our end, the metrics will be okay, and the reports will be live, you name it. But we know that there's going to be dependencies through the asset registry. So we know that this is connected. Rodrigo just mentioned there is a big asset registry. We know how things are connected, which is a tricky thing to do in a decentralized setup. But since we know how they are connected, we can instantly send out warnings to the teams that might be affected. So I say instantly, but it comes with a little bit of a caveat. Remember the SLOs. We have to assume that these are breached. So if someone from supply wakes up very early, might have a newborn, might be very dedicated, they fix it within the times of the SLOs, all is well. If not, the warnings are popping up. And the warnings have links that also show which of the files may have, or which of the tasks may have failed. But the beauty starts, so this is good because we'll have more effective communication. Some are call to action, some you know that it's depending on other teams. We don't have to go through the cycle of pointing fingers and shouting. But the beauty comes that through this asset registry, when this task is fixed by the supply team, we can use the connections to automatically apply a callback and trigger the downstream tasks. So in a way, we have a fully decentralized way of working, decentralized setup, but the DAGs are still sort of connected as a centralized single DAG in this way. So what this also unlocks is that we can set up a landscape of metrics. This is also a tricky thing to do in a decentralized landscape. Know what everyone is doing, how the overall health of the data landscape is looking. So now we have this, through this generator, that we can send these metrics and we can create graphs like these that show what is our overall health of data landscape. There's more than this. You can also go to critical points. Which points have many dependencies, tend to break more than they should? Where should we put our focus? So with that being said, let's wrap up with some outcomes and lessons learned. I think if I want to paint a picture of what the situation looked like at first, I can do it best by showing you this Wild West situation, where the teams are pointing, they're in a Mexican standoff, they're pointing towards one another. Who owns this piece of land? Why is there someone shooting someone there? Who owns this? Who broke that? It's difficult for the sheriffs, if I do say so myself, the sheriffs to keep order in this town. So what this generator does is it creates a scenario that looks much more like this. A civilized world where we speak the same language, we have some constitutions that everyone follows, and there is much more, it's much easier to keep order in the room. So I'll take you back. This is the last time I'm showing this cartoon, don't worry. I'll take you back to this cartoon, and what I want you to recall is why I color-coded them. Situations where teams create completely different solutions because they have a completely different set of skills. And in a fully decentralized setup, they'll find very creative ways to come up with all the problems that they're facing. What the generator allows us, or forces them to do, is to create pipelines that fit, or that are constructed of a limited set of building blocks that we define centrally. So what it looks like after going through the generator is more like something like this, where we have the color codes for who owns the components, but the actual core components of which the pipelines are created of become the same. So it's much easier to scale the system, but also to connect the dots together, to connect the tasks. Finally, if we want to do an upgrade from Airflow 2 to 3, that's been recently come out, or we may want to use a different solution for scheduling. You may even want to go old school and go cron, or you may even want to try something new and train an army of monkeys to wake up early in the morning and press the buttons, whatever floats your boat, I would say. The challenge you'll find is that each team, denoted here by the colors, will have their own solution with their own dependencies, their own environment, and you have to go one by one and play that little game we used to play when we were young, put the right shapes into the right holes, mold the shapes into something that fits in the new solution. So all of these have to go into triangles, and you have to coordinate with that team because you can't, it's very difficult to upgrade a part of Airflow to 3 and the other part will keep it as is. You even can't if you have a single instance, which we do. So we say, ain't nobody got time for that. We don't want to go team by team, figure out the dependencies, coordinate a whole rollout plan. We use the generator to grab these different teams or cramp these different components into one, so that from a centralized place, we can make the changes in the abstraction layer, so the user interface doesn't even change. So for the user, nothing could happen. They could wake up, open Airflow or any scheduling tool and be like, why is this suddenly upgraded? We'll talk to them. We will tell them about this, don't worry. But in theory, we could do this. So it's much easier to maintain the platform as well, to scale it, and to upgrade systems. And with that, I would like to thank you for your attention and leave some room for questions.
That was amazing, guys. Yeah, that was amazing. Thank you. Who has a question? Here, first.
I have a few.
Hi, thank you for your talk. It was very insightful. I have a question. I saw you mention SLOs, like somehow you derive SLOs and from its dependencies. Like, could you explain a bit how you do that?
Yes,
Do you want to take it?
I can take it.
He's the smarter one, so.
So the idea is that the users need to declare the SLOs for the things that they are producing. And we basically save that in a JSON file. And then in Airflow, I don't know how familiarized you are, but there are sensors that have a timeout. So we translate that SLO that someone declared to the timeout of the sensor. So then when the timeout is exceeded, you will get some action from the scheduler, and you get that alerting that Oscar showed. But basically is the contract part that Oscar showed with the little meme picture. So we trust each other, and people need to take care of that, and then we have the monitor to understand if someone is not meeting those.
Okay, thank you. So it's the users that define it. It's
Yeah.
not like auto-calculated somehow.
Yeah, I mean, we have some suggestions for it, right? Like you cannot say like, yeah, I'm gonna finish at 3 in the afternoon when I wake up. But yeah, it's user-defined.
They're part of this scheduler file that we, so Rodrigo showed parts of it. If you all crumble them into one, that's how teams configure. And part of that file will be to point to the assets and set the SLOs that are agreed upon by the team.
Yeah, thanks for the talk. You went into the developer experience, which consists of defining YAML files, as I understand it, for defining the graphs, and then also writing SQL and Python components. How do you test?
So in CI, we can already sort of combine all the components, and we can do a test within the environment of the user itself. Right? So we have, in our CI, we connected to an instance of Airflow. We send out the DAGs. So everything locally is tested there. When it comes to the dependencies, we can do it through the asset registry. So we can verify things. So this is how we test how things are connected. And when it comes to actual runs in production, I think the power that a generator like this unlocks is that you have complete control over the building blocks of which the DAGs are generated out of or made out of. So this makes for a less strain on test side, so you don't have to go one by one to test things because you know the behavior that your generator is going to get because we generate every line of code that comes out of said YAML. So this loses some strain into how we test this. So we have this fully sort of duplicate Airflow instance where we can run everything in a mirrored way, but we find that in practice it's very similar to what we have in production. So it takes a lot of strain off. So as a platform engineer, I can recommend everyone to look into. I don't know about our users here. How I see thumbs up.
But also I think there are two parts of testing. One is like what's happening inside of each of these nodes, and for what's happening inside of each of those nodes, we are not responsible for that because, for example, if you write a Python ingestion thing, yeah, you unit test it there. It's the owner. We don't care what it's inside the Docker file that you send to, to generate the images. And in DBT also, it's like, okay, you are responsible for the code that you're writing. We have our own unit testing framework for DBT. but it's not tested in the scheduler part. It's tested in the CI part that takes care of dbt or takes care of the Python thing that you wrote or the Spark thing that you wrote. So, yeah.
Hello, thank you. Sorry if I missed it, but the dependencies of the models within one GitHub repository are managed by the team itself, or the users which had generated their models, they don't care as well, and you take it from dbt artifacts file and, I don't know, inherited it later on in Airflow? How do you make it? Thank you.
Yeah, so the things that are internal, for example, all the dbt dependencies for each task that is in dbt, we expand the manifest of dbt, and we generate one task per model, and we connect them through dbt. And then the magical part is that we can connect those individual dbt nodes with things that are outside that dbt manifest. That could be other dbt thing or other Python thing. And we do that by declaring in the sources, for example, the name of something that we want to read, or in things that are non-dbt in the assets that dbt produces. So all are connected like that.
I think also the power of this is that as an analytics engineer or analyst, you don't have to worry about scheduling things. You can actually focus on driving impact through data products. So this becomes business as usual. Like when you saw the PR, people are doing dbt things. They don't have to worry about Airflow. They don't even have to change the configuration because artifacts that dbt create are used and taken by the generator to ensure that scheduling is done automatically. So yeah, it saves a lot of time there.
Thanks for the presentation. Question on rolling back. Do you have versioning somewhere, or when things go wrong that you're kind of responsible, how do you fix it?
You mean for the generator? So we don't roll back, we roll forward.
There's the famous quote by Denzel Washington: "If you fall, fall forward."
Yeah. No, and so in the scheduler YAML file, the first part that I didn't show is that you put a version of the generator. So then you have that, and then, yeah, we usually do something that we call fear-based semantic versioning, where we are afraid of breaking something, we just change the minor. And when we are confident, we don't do nothing, because, yeah, that's it. And then we can roll out like in one or two small of these tests if everything goes well, and then roll it out to everyone. But yeah, like a version of the generator itself.
Hello. Thank you for the presentation. I have a question on the data availability and data quality. How do you ensure the data quality within the kind of constraints of the SLO? Are the SLOs bounded only by like timeliness constraints, or because I didn't really see in this architecture on the workflow orchestration where does the this like service sits?
Mm-hmm.
Thank you.
Yeah, thank you for your question. So the idea is that here you are connecting different Airflow DAGs, and a failure in a task will result in a blockage of the downstream tasks. So if the task didn't run, you can assume that the data is not correct or fresh. But also we have the situation where the task could run with, I don't know, source data that is outdated. And for that, we mainly focus on using dbt freshness checks that ensure us that everything that starts is fresh. And then you can basically say that if a task succeeded, it means that the things are fresh. And then in Airflow, the tasks are connected with each other. So then if a task doesn't succeed, it means that it's not fresh.
Amazing. So we have a lot of questions, but no more time. Thank you very much for being part of 2025 PyData Amsterdam. A last round of applause, please.